Welcome to this explainer. Look, today we're unpacking what honestly might be the single most important piece of modern tech architecture you've probably never even seen. I'm talking about the Model Context Protocol, or MCP for short. We're going to dig into the invisible infrastructure that's finally allowing artificial intelligence to step right out of a chat box and take real, actual action in the world.
We're living through a massive paradigm shift right now. Until very recently, AI assistants could really only talk to you, right? They could tell you how to send a Slack message, or write the code to query a database, or even explain how to mint an NFT. But they couldn't actually press the buttons. They couldn't do it for you. So we're going to explore this crazy transition from AI that merely gives you instructions to autonomous AI agents that actually execute tasks in the real world.
Here's our quick roadmap for today. We'll hit the integration problem, how MCP works, its rapid adoption, those hidden security risks, the Web3 privacy solution, and finally, the future stack. Let's dive in.
Okay, Section 1. The AI tool integration problem.
To really get why MCP is such a game changer, we have to look at the massive bottleneck that was holding everything back. Before this standard hit the scene, every single AI application had to write a custom integration for every tool it wanted to use. OpenAI had its format, Anthropic had theirs, totally incompatible. If you had, say, 10 AI apps and 100 tools, you needed 1,000 bespoke integrations. It was an M times N nightmare of rotting connectors, driving developers absolutely crazy. But MCP brilliantly collapsed this math. It turned that nightmare into an M plus N solution. Every AI app implements the client once, every tool ships a server once, and boom, everything composes automatically. It drops 1,000 custom connectors down to just 110 standard ones.
Anthropic, the folks who originally developed the protocol, honestly hit the nail on the head. They call it the USB-C for AI. Just like USB-C ended the absolute misery of proprietary device cables we all used to suffer through, MCP acts as the universal port between any AI application and any external tool. Any AI that implements it can use any MCP server. It's really that simple.
Moving right along to Section 2, how MCP actually works.
So how does this universal port do its thing under the hood? Well, the protocol is built on top of plain JSON objects and split super cleanly into 3 roles. First, there's the host. That's the AI app you actually open and look at, like ChatGPT or Claude Desktop. Then there's the client. These are the invisible connection managers living inside the host, acting as the plumbing. Finally, you have the servers. These are the external programs exposing capabilities, usually wrapping a product like GitHub or Stripe, and they're controlled by the tool vendors themselves.
Now, these servers basically offer 3 distinct things to the AI. First up, tools. These are functions the AI can call that take physical action with real-world side effects. Think creating a GitHub issue or executing a crypto swap. Second, resources. This is read-only data, like pulling a Google Drive doc or checking a blockchain balance without changing anything. And third, prompts. Reusable templates that save you from typing the same complex instructions over and over again.
The absolute coolest part is what this composition looks like in practice today. From just a single user prompt, an agent can now read a product spec in Notion, scaffold a working app, and deploy it to Cloudflare. And by the way, using a compression technique that cuts token usage by up to 99.9%, which is wild. Then open a pull request on GitHub, and finally ping your team on Slack. A completely seamless cross-platform workflow that was quite literally impossible 18 months ago.
All right, Section 3, rapid industry adoption.
Because it solved such a massive, painful problem, the adoption speed for this back-end tech was entirely unprecedented. Anthropic released MCP in November 2024. By March 2025, OpenAI adopted it. Less than 2 weeks later, Google DeepMind jumped on board. And by December 2025, it was donated to the newly formed Agentic AI Foundation under the Linux Foundation. In just 15 months, it went from a single company's open-source release to a shared industry standard adopted by every major tech giant.
And that massive support translated into sheer scale. By early 2026, the ecosystem exploded to roughly 8,000 to 10,000 public servers, driving over 97 million monthly SDK downloads. It just proves that in tech, standard protocols almost always beat isolated, walled-off features.
Which brings us to Section 4, the hidden security risks.
We really have to look at the other side of the coin here. This incredible open interoperability introduces a massive security blind spot. The core vulnerability is called tool poisoning. See, every tool has a description that the AI model reads, but that you, the user, typically never see. So what happens when a malicious server hides instructions inside that description, secretly telling the AI to perform actions you never actually authorized?
In a terrifying proof of concept published back in April 2025,
an attacker disguised a data exfiltration tool as a simple math function. The hidden description commanded the AI to secretly read the user's private SSH keys and pass them along as a side note parameter. So the user thinks their AI is just doing some basic arithmetic, but in the background, the attacker is silently stealing their most sensitive security keys.
When the security community benchmarked this, the results were pretty shocking. They found roughly 5.5% of public servers contain poisoning patterns. And it gets worse. When users left tool auto-approval enabled, these attacks had an 80% success rate. A tool you trust today can silently change its behavior tomorrow, which means keeping a human in the loop to manually approve those tool invocations is absolutely crucial right now.
So how do we fix this? Let's get into Section 5, Confidential MCP and Web3.
To solve this catastrophic privacy leak, especially for agents that are literally handling real money or DAO treasuries, the industry found its native fit over in Web3. Web3 builders immediately recognized MCP as the ERC20 standard for AI tools. Just like ERC20 made tokens automatically play nice with every wallet, MCP makes tools play nice with every agent. This sparked a massive integration wave across Ethereum, Solana, and Coinbase's base.
But the ultimate privacy fix comes from the Oasis network, using something called Trusted Execution Environments, or TEEs. Think of a TE like a tamper-proof hardware black box inside the server's CPU. Data goes in encrypted, the computation happens inside where literally no one can see it, not even the person who owns the machine, and then the results come out encrypted.
The contrast here is just stark. Standard MCP requires you to put API keys in plain text config files. That means your inputs, prompts, and strategies are entirely visible to whoever runs the server. Someone could easily front-run your AI's trading strategy. But a confidential Oasis ROFL server completely seals those inputs. It generates its own keys inside the hardware enclave, meaning no human ever touches them, and it perfectly prevents front-running. It finally makes the AI genuinely autonomous.
Finally, Section 6, the future of autonomous agents.
We're now looking at a fully composed, secure future stack that bridges the gap between digital thoughts and physical actions. By stacking MCP for tools with things like Google's A2A protocol for coordination and the X402 standard for machine micropayments, developers aren't choosing between AI and Web3 anymore. They're actually building a trustless, automated economy.
The integration war is officially over, folks. The standard for how agents reach out and do real work in the world has been firmly established. MCP is that critical piece of the autonomous puzzle, and it has absolutely won the market.
So the final question isn't whether you'll use this technology. You absolutely will, for sure. The real question is, are you going to build on a default architecture that leaks your agent's private keys to whoever runs the server? Or will you choose a confidential architecture that keeps your agent's true autonomy verifiably secure? That's the chapter being written right now. Thanks so much for joining me on this explainer. I'll see you next time.